Gunda Math over here, and this is 1988 AIME problem number 11. And here's a view of this problem. Let W1, W2 all the way until Wn be complex numbers. A line L in the complex plane is called a mean line for the points W1, W2 all the way to Wn. If L contains points, aka complex numbers, Z1, Z2 all the way to Zn, such that the summation from k equals 1 to n of Z sub k minus Wk is equal to 0. And then for these complex numbers, there's a unique mean line with y-intercept 3. Find the slope of this line. So first, let me try to digest this thing over here. K equals 1 to n of zk minus wk is equal to 0. So what does this tell us? z1 minus w1 plus z2 minus w2 all the way until, well, we're going to go all to phi, right? So z phi minus w phi. So we can now regroup this as z1 plus z2 plus all the way until z phi minus w1, w2 all the way until w phi, right? So we can find complex number z such that this is satisfied. We have a mean line, right? Okay, so all we did here was we applied the summation definition and regrouped terms. So now what happens is we can easily find W1 plus W2 plus W3 plus W4 plus W phi because we're given all of them over here. So let's first find this. Let's see, the sum of the real part would be 25, 16, 16, 17, 3, right? And then the sum of the imaginary part would be 170, 234, 434, 461, 504. Yep, 504. 504i. So therefore we must have that for this line to be mean, we must have z1, z2 all the way until z phi equal 3 plus 504i as well. Great. So now let's use the information we haven't used. We haven't used that the y-intercept is 3. And we want to, okay, so we want to find the slope of this line. So the line is of the form y is equal to mx plus 3, right? And then for they're going to be complex numbers zi that are on this line, right? So let's let z sub I equal x sub I plus I y sub I. Actually, that isn't the best choice of notation, but I guess that'll do because we have a subscript of I and an I in the complex numbers. But I guess this will do. So, and then any complex number that satisfies this mean line will have a form of, any z that satisfies this will have a form y sub I is equal to m times x sub I plus 3, right? Okay, this is good. All good. So now, let's use some other information we haven't used, and that is, we know exactly what the sum of the x sub i's and what the sum of the y sub i's are going to be. So we have that x sub 1 plus x sub 2 all the way until x sub phi is nothing but the real part of this, which is just 3. And now the sum of the y sub i's will be y1, y2 all the way until y sub phi, and this will be equal to 504. So let's implement this somehow into this. So from this, what I'm going to do is I'm going to solve for x sub I. X sub I is nothing but y sub I minus 3 over m, right? And now I see straight away how we can find m. We just simply sum the x sub i's using this form, right? So x sub 1, x2, x plus x sub 2 plus x sub 3 plus x sub 4 plus x sub 5 is going to be equal to 3. And that's equal to y sub 1 plus y sub 2 all the way until y sub 5 minus this. How many times? Well, we're doing y sub 1, y sub 2. That's 5 times, so we need to subtract 15 over m. Okay, from this, what is the sum of the y sub i's? That's 504 minus 15 over m. So 504 minus 15 is equal to 489. Yeah, 489. So 489 over m. So solving, we get m is equal to 489 over 3. And then we can do long division. 489 threes are 1, 3, 1, 8, 6, 18, 0, 9, 3. 163, and we are done.